Alright, so today we're going to go over those 3-5, which is on continuity. Basically talking about, is the function continuous at a certain place, and if it's not, what kind of discontinuity is it? There's 3 different types. So the first little section of our notes here, it says the graph displays infinite discontinuity at a point C. So as you approach the x value from either the left or the right, so coming from either side, what happens to the function is it shoots straight up to positive infinity, or it shoots straight down to negative infinity. So the graph actually is going to look like infinite discontinuity. So you can see, and I'm going to use my cursor just because, you can see as you're coming along, it shoots straight up once you hit, in this dotted line here, I know you can't see it, but this dotted line here, that's where I'm trying to figure out where it's continuous at. So that's the point C, where it says at a point C. So if we approach from the left, so again we're coming along from the left, it shoots straight up. We're coming from the right, it shoots straight down. Alright, so another type of discontinuity is jump discontinuity. And that's basically where if you're coming from one side, you hit a certain value. If you're coming from the other side, you hit a different value. The graph jumps. So if the graph stops at one range value, or a y value, and then it begins, so the graph begins again at a different y value. So like our piecewise functions, a lot of those display jump discontinuity. So you can see jump discontinuity, you're coming along. So if I'm thinking about, I'm coming here and I hit this value, but then when I begin again, I jump up to here and keep going. So it's not continuous because it changes the y value you were at. Okay. And the last type is called point discontinuity. So if we're coming along to a point C, and there's an x value in the domain for which the function is undefined, but the pieces of the graph match up. So basically, there's a hole in the graph. So you can see as you are, you're coming up here and it's working, and then you hit this hole right here, but then you keep going, they still match up. So the right and the left match up at this value in the middle, but the problem is that value is not defined. It doesn't work for that function. So that's point discontinuity. Okay. So there are 3 parts to our test. So first of all, it has to be defined at that point C. So if I'm trying to say, is it continuous at the value x equals 2? Well, then I plug in my 2 for my function. So I do f of 2. In this case, they just use a generic C. So I have to make sure it's defined at that. And then I'm saying, as it approaches, or will it approach the same y value on the left and the right sides? So basically, are we going to come to the same value if I test it from the left and I test it from the right? And we do that by using values that are slightly opposite. So, for instance, if I was testing it at x equals 1, so from the left, a value I might test would be 0.999, because that's coming from the left. Okay, there's smaller values if you think of a number line. And coming from the right, I might test 1.001, because it's something just slightly bigger. You want to see, do they match up? When I test both the left and the right, do they hit the same y value? Okay. And then the last test is basically to say, is the y value that the function is defined for in 1 and approaches from the left and the right, is it the same? So basically, is test 1 and test 2, do they produce the same number? If they don't produce all of the same number, it's not continuous. Okay. So let's look at this first example. So test 1 is asking me to see if it's continuous at x equals -1. So all I'm going to do is I'm going to plug in -1 for my function. So I have -1 squared plus 1. Again, I'm just plugging it into that x. So now when I do this, -1 squared is just 1, so -1 plus 1 is 0. Okay, it's defined. Test 1 works. Okay. Then I've got to do test 2. So test 2, I'm going to check it from the left side. So a value that would be to the left of -1. So I think, like, here's -1, here's my number line. On the left side would actually be -0.001. So that one's slightly to the left. So I'm going to test that. So -1.001. Okay, if I plug that in, if I type that in, I get something that, like this, -0.002, which is basically 0. So I'm going to say approximately 0. So we get 0. And now if we need to test it from the right, so we think of a value that's like -0.99, that would be from the right. So we have f of -0.999. If I plug that into my function, I get something close to 0.0019, which is basically 0. Okay. So test 2, they both line up. We both have a 0 and a 0. So that's important. If they don't line up, then it's not continuous. But then our last test really is not, I wouldn't say a test, but does test 1, does that equal test 2? And if it does, then that means it's continuous. So this one is continuous, so f of x is continuous at x equals -1. Alright? And we're going to move to the back. We have 3 more examples on the back. So example 2. The first thing it's asking us is test is it continuous at x equals 2? So test 1 is that we've got to see if it is actually defined at 2. So g of 2, we're going to plug that in. 3 over 2 minus 2, which I get 3 over 0, which means it's undefined. Okay, so it's not defined, which means it's discontinuous at x equals 2. And this type of discontinuity is infinite. Okay, so when test 1 fails, it ends up being this infinite discontinuity because it would shoot up to infinity or down. You could also look at it and graph it to see. Alright, example 3. So test 1 is making sure that h is defined at 0. So remember, this is the greatest integer function. So the greatest integer of 0 that is less than or equal to is 0. So that's test 1. It is defined, so we can go ahead and move on to test 2. So from the left, we would want to test. So from the left would be in the negative, so -0.001. So if we plug that into the greatest integer function, we actually end up getting -1 because it's less than or equal to. And then if we test it from the right side, so from the right side we'd end up being in the positive, so it'd be like 0.001. that into the greatest integer function, we actually get 0. And if you look, test 2, they don't match up from the left and the right. So that actually tells me that it's going to be discontinuous at x equals 0. And this type is jump discontinuity. Because it stops at one side and begins at a different value. Okay. So we didn't have to do step 3 or test 3 because test 2 failed us, so no reason to keep going. In example 4, it's a piecewise function. So test 1, we got a first test if j is defined at 1. So if you look at 1, if x is 1, that means I get negative 3. So it is defined at j of 1. The next thing is testing from the left and the right. So from the left, we would have a value like, so from the left of 1 would be like 0.99. And because that is less than 1, we would end up using this, because 0.99 is less than 1, so we'd actually be plugging in to this function, the top one. So we end up getting 2.998, which is just about 3. We're going to round that to 3. Then we got to do it from the right side. So j of 1.001. And that's a little bit bigger than 1, so I actually need to use this value. It's greater than 1. So 4 minus 1.001 squared. So that gives me 2.997, so it's approaching 3. So if these match up, I both got 3. And now my test number 3 is test 1 equal test 2. So test 1 I got negative 3, and test 2 I got positive 3. So they are not equal, which means this is going to be discontinuous. Spell it right. Discontinuous at x equals 1. Alright. Okay, so you should now be able to find your homework. You get it from the substitute, and you can start working on that first part of that homework. Okay?